Some more Maker Advent, and today it's more Maker than Advent because we've made this. This is a shortcut keyboard. It's got 4 keys. Inside is a Adafruit QTPy 2040. That's Adafruit's small version of an RP2040 Raspberry Pi Pico board. Teeny tiny board, great fun, and it's acting as a USB keyboard because CircuitPython, Adafruit's version of MicroPython, has a library which will enable it to become a USB HID device, a human interface device. So I've got that running as a USB keyboard, but I needed 4 keys for it. 4 keys? That's almost a 2 Ronnie's joke. Not 4 candles, eh? Handles for forks. So I've got a breakout in there called a Neo key, a 1x4 Neo key. Now what it is, it's an I2C device which uses STEMMA QT. That's a lot of acronyms there. Basically, I2C, a communications protocol, is used to communicate these 4 keys to the QTPy in there, and that uses a connection called STEMMA QT, which is like a polarized connection. It can only fit in one way. It's really cool. I've bought into that system a lot. I've got a lot of the breakouts. Just means you can wire up electronics really fast, really easy as well, so kids can do it. So wired it all up inside. It's simple inside. I'll show you at the end of the video. And I 3D printed a case which Adafruit has also put online to use. Adafruit's example was all about a like an emoji keyboard. So you know, cat emoji, happy emoji, that sort of thing. But I wanted a shortcut keyboard because I do a lot of work in this. This is DaVinci Resolve. All the videos edited for Maker Advent are done in DaVinci Resolve. So what I've got set up here is 3 screens. You can see the code that's running on that QTPy 2040. Top right you can see the keyboard with my hand waving around. Bottom right you can see OBS. I'm going to step through the code pretty quick. This is Adafruit's standard code for this. I've just taken it off their website, which they freely do. Their resources are fantastic. And I've just tweaked it with a little bit of stuff that I've used in a Tom's Hardware tutorial I did a couple of years ago now. So we've got some imports. At the start we've got import board. That's basically CircuitPython's way of saying, right, let's use some GPIO stuff. I've then got the special one for the Neo key, so I can use the Neo key's features, the LEDs and reactor button presses. All of these are USB HID stuff, so USB human interface device. So it says, okay, we're making a USB HID device. It's going to be a keyboard. It's going to have a layout of US. It doesn't really matter, so I'm only using 4 keys. And we're going to use key codes. So if we need to send any special keys, so we can say A, B, C, we can send that, no problem. We can send backspace, spacebar. Basically, if it's on a keyboard, we can send it. There's also another one called consumer keys, which are the special keys on a keyboard. You know, the pause, the play, the volume controls, the media keys. They're special. They're called consumer codes. And lastly, we've got time, which is going to just create pauses in the code. So we're going to say, right, we've got an object now called keyboard. Keyboard is our way to interface between the keys and the QTPy. The layout's going to be US, and we're using I2C bus. And for this I've had to alter the code slightly from the example to use board.stemma I2C. If I don't do that, it'll think I'm trying to use GPIO pins on the board, but I'm not. I'm using the STEMMA QT connection, which I'll show in a minute. I then tell the software, right, I've got a Neo key 1x4 plugged in on I2C, and there's its address on the bus. If you don't have that address, it'll just go, I don't know where it is. And then this bit is just super simple. So while true, so forever, if the first key on Neo key is pressed, print spacebar. So that's going to be the spacebar. Turn the pixels off for that specific key. Then send the key code spacebar. In other words, press the space key. Right on the next line. No delay whatsoever. Release. Then we add a delay. If we add a delay after sending the key code spacebar command, it'll think we're holding down the key. So I use release all to say, right, hands off the keyboard, release, don't press it again, but wait 0.1 of a second, then check again. If the key's not been pressed, I want it to light up, and in this case, using hex, we've got 0, 0, so that's red, so there's red, that's off, there's green, that's on, and there's 0, 0, off. If you know your hex color codes, you can go wild on this and make some really cool colors. I'm sticking to the basics. So, if spacebar key is not pressed, it shows up green. And we can see here, it's green. Just about see it's green. There you go, we can just see it. So if key 1 is pressed, and that's key 1 there, that's backspace. Let's highlight it, there you go. If key 1 is pressed, print backspace. turn off the LED for that key, send the backspace command, release the keys, pause for 0.1 of a second. If the key's not been pressed, using FFFF, which is red and green mixed together, which weirdly makes yellow in this. There you go. If key 2 is pressed, print Blade. No, not the Wesley Snipes movie, although that is a great movie. Saw that at the cinema as a teenager. If it's pressed, turn off your LEDs, send key code B, because in DaVinci Resolve, the Blade tool is key code B. Blade's what you use for slicing clips up. Then release the keys, pause for 0.1 of a second. If the key's not pressed, using FF0000, red on, keep the red key, keep the red light on. Final one, Neo key 3, is pointer. Pointer is so you can select clips on the timeline. So it prints pointer, it turns that key's LED off, it sends key code A is the pointer key, release the keys, pause 0.1 of a second, and if you don't press it, it lights up in 00FFFF, which is greeny blue, like a tealy blue. There you go, that's the code. So all this code is saved to the QTPy 2040 as code.py. We can just see in the top corner here it says code.py. Just like MicroPython has main.py, CircuitPython has code.py. If you save code as that file, so code.py to a CircuitPython device, it will auto run on boot. So I can simulate that by just starting the code up. And if I go to DaVinci Resolve, and I can move the timeline around here, but I can use green to start and stop, so that's spacebar. I can use red, which is blade. If I just click on red now, you'll see the point which is waving around here become a razor blade. And I can cut sections. I can select a section by pressing A, so there's the blade tool running. If I press blue, which is A, pointer, becomes a pointer, and I can move that around. Or if I want to delete it and not destroy the timeline, if I use the delete key here, it shuffles the timeline along to make up the space for the deletion. If I use the backspace key, it keeps it all together in the right place. So if I click on the start of this intro and press backspace, which is yellow, gone. There's the undo key on the keyboard as normal. So there we go, that is the shortcut key for DaVinci Resolve. This can be a shortcut key for anything. You can put any key codes you want in. It can be media keys for volume, it can launch applications, anything you want really. But let's have a look inside. I'm just going to unplug it. Underneath I've got some rather fetching rubber feet that I got in bulk from Amazon. Got some M2.5 screws holding stuff inside. And it is lifting a little on one side, but I'm going to glue it together. This isn't the final case, this is just me being lazy, and I had green PLA on the printer. I'm going to do it in, I don't know, black would be fitting for the keyboard, so it's like a dark grey. But you know, I think something a little more nice would be, well, a little more colourful. Yellow. I've got lots of PLA. Anyway, to get inside, I'm just going to take the keys off. These are just Kale switches. Never know how to pronounce them. Kale yellow they are. There they are. And they just poke through the top. And inside, that's the Neo key 1x4. There is the QTPy RP2040. And that connection between them is the stemma QT connection. It's a teeny tiny wire, or 4 wires that just goes across. And that's just held in place with 4 screws. The keys pop off as well. These are just standard mechanical switches, Kale yellows, slightly clicky. I'm more of a cherry red or Kale red myself, or a blue. But these yellow ones work well, and I had them in stock. Adafruit's case, Adafruit's boards, so the Neo key and the QTPy RP2040, all works rather well. Nice piece of kit. So I'm going to be using this to edit the videos, so it just makes sense. That's all for today. See you later.